Hello everyone, I am glad to see you on my channel dedicated to testing and IT. And I am especially excited to welcome you to the first video of my basic course on mobile app testing. By completing this course, you will gain foundational knowledge in mobile app testing that will help you in your career. Let's go! Types of mobile applications. We will begin our introduction to mobile app testing by exploring the different types of mobile applications. In my opinion, this is an important topic to understand for a general grasp of the mobile app world. It also helps to understand how they are developed, what features they have as a result, how to test them, and which tools to use. This is also a question often asked in interviews at companies involved in mobile app testing. Essentially, we can identify four main types of mobile applications: native, web, hybrid, PWA, Progressive Web Application. Native applications. A native mobile application is an app created for a specific platform and written in the platform's native programming language. The two most popular operating systems for smartphones are Google's Android and Apple's iOS. Since Apple and Google are interested in making it convenient for developers to create applications for their operating systems, they offer their own custom development tools, software development kits, SDK, native languages, and more. A native programming language is a natural language for each operation system. To create a mobile application for Android, you need Java or Kotlin, while for iOS you use Swift or Objective-C. Java is the native language for Android, and programmers wrote applications in Java before Kotlin appeared. Java is still widely used, but it's less common in mobile development. Kotlin is positioned as a more modern and convenient language. The same situation happened with languages for iOS. Initially, Apple apps were written in Objective-C, the official language of iOS. However, this language had drawbacks such as a complex syntax. Therefore, Apple created a new language, Swift, which is simpler, more convenient, and easier to learn. Since different operation systems require their own languages, a product designed for Android cannot be installed on iOS and vice versa. The program will be fully adapted to one system, its interface, requirements, and capabilities. Unlike web application and progressive web applications, native applications must be installed before use. To do this, you download the installation file from an app store such as Google Play or the App Store, or the developer's official website. There are also other ways to install native applications. You can build the app code directly onto your device using developer tools like Xcode or Android Studio, or by downloading the installation file to your device. This is more relevant for devices running Android. Native applications are designed specifically for a particular platform and can utilize all the device's features, such as the camera, Bluetooth, GPS, notifications, and etc., of course with permissions granted. Depending on the purpose of the native application, it may work fully or partially without an internet connection, such as a mobile calculator. Native applications perform better than web applications because they are not limited by the capabilities of the mobile browser. In other words, they directly use the device's resources, like its processor and memory. Furthermore, native applications can access all of the device's features if the user grants the necessary permissions. On the other hand, a browser-based applications, for example a web application, which we will discuss later but mentioned here for contrast, is limited by the functionality and permissions of the browser it runs in. For instance, a native app can access the phone's camera, GPS, or compass, while a web application can only access if the browser itself has permission. Let's look at examples of native applications. I believe most of the apps on your mobile phone are native. For example, Lensa, an app for photo and video editing, plus AI avatar generation. I mentioned it here because I currently test this app and may refer to it when demonstrating specific aspects. Shazam enables users to recognize songs by humming a tune or playing a short clip. It can be used offline if there is no internet, as long as it has access to the microphone. Spotify, a highly popular streaming service for listening to music, podcasts, and audiobooks, leveraging native app functionalities to instantly connect with the device's speakers. Waze, a real-time navigation app that provides traffic, roadwork, and accident information and suggests the optimal route using GPS data, a functionality that will be harder to achieve in a web or hybrid app. Advantages of native applications: fast performance and high efficiency. Apple and Google regularly update and improve their operating systems, which enhances the stability of native applications. Operating systems fully support these apps, resulting in fewer errors and crashes. This means users are more satisfied with a product that runs on a more stable platform with fewer bugs. Access to the device's hardware, such as geolocation, camera, microphone, accelerometer, light sensors, calendar, and push notifications, providing extensive functionality, can fulfill a wide range of requests from clients and users. Beautiful interface in line with platform guidelines. Ability to work without internet access. Disadvantages of native applications: multiple code bases. Development cost. Several developers or teams are required. The app takes up storage space on the device. Each release or update must go through a review process before it reaches the store. Limited platform coverage and incompatibility with other operating systems. For any update, users need to perform an update to receive new features. A large number of devices are needed for testing. Now, let's take a short break to give our brains a rest from the all new information. During this break, I would appreciate it if you could give this video a like. Your like will help boost this video and show your support for me. Also, don't forget to subscribe to the channel, as I will be sharing many more interesting and useful videos on testing and IT, not only mobile testing. And one more thing, if it's not too much trouble, please leave a comment below. Let me know what you liked or didn't like. Your feedback is valuable, as it helps with video promotion and gives me important insights. A mobile web application is essentially the same web application, adapted for viewing in a mobile device's browser. Let's start by visually comparing the difference between native and web applications. The interface of web application often differs significantly from that of a native application. Now, let's compare the layout of elements in the web version of Google Maps and in the mobile app. For instance, Google Maps native on the left versus web on the right. Web applications are not actually mobile applications in the traditional sense. Essentially, they are websites that are adapted and optimized for any smartphone and look similar to native apps. They use web technologies and are not limited to any specific platform during development, unlike native applications. To use them, a browser and an internet connection are required. When launching a mobile web application, the user performs all the same actions as when visiting any website and also gains the ability to install it on their home screen by creating a shortcut to the website. If you didn't know that this functionality exists, you can Google it. Any website can be added to your phone's home screen as an app, and you won't need to open the browser every time. It's a handy feature. Web applications are cross-platform, meaning they can function independently of the device's platform. An obvious drawback of this type of application is the loss of functionality when there is no internet connection. Another downside is performance, which is average compared to other types of apps and depends on the internet connection speed provided by the service provider. In addition to the above, web applications cannot access system features and device functionality such as Bluetooth, the camera, and etc. In terms of testing, the first thing you should determine is which browsers need to be supported. A prominent example of a web application I mentioned earlier is Google Maps, which you can open in your device's browser. You can also compare this with the equivalent native app and see how they might differ quite significantly in terms of graphics and functionality. Advantages of web applications: easy to update, easy to make changes, no installation required, compatibility with different operating systems, no need for a large number of test devices. Disadvantages of web applications: requires an internet connection, limited access to mobile device features, no access to the App Store or Google Play. Apps are not cataloged in one place, making them harder to find. To finish discussing web applications, I want to talk you about progressive web application. In many sources, it's highlighted as a separate type of mobile app, but to me, it's clear from the name that it's a web app, just developed using different technologies. This technology in web development visually and functionally transforms a website into an app, a mobile app in the browser. Progressive web application is a hybrid solution and allows an app to be opened via a mobile browser. It retains much of the functionality of a native app. Push notifications, offline mode, access to device hardware with limitations, the ability to add a shortcut icon to the mobile device's home screen, visually indistinguishable from a native app shortcut, and more. Advantages: progressive web app is supported by the most popular operating systems: Windows, iOS, Android. It can be downloaded on desktops, smartphones, tablets, or terminals in retail spaces, for example. Updates are added remotely by developers. Users see changes and improvements without needing to download updated themselves. Progressive web application is indexed by Google and other search engines. Thanks to the service worker script, which runs in the background of the browser, and the caching strategy, offline functionality is supported. The front-end is separated from the back-end. Less time and resources are spent on developing, redesigning the progressive web applications, design, and client integration logic. Progressive web applications can be installed without using Google Play or the App Store, and despite restriction on installing apps from unknown sources. Antivirus programs are also friendly to progressive web applications. At the same time, data is transferred via HTTPS, making progressive web app secure. Since February 2019, progressive web applications can be added to the App Store and Google Play, giving users the option to download the app from familiar sources. Disadvantages: not all devices and operating systems support the full range of progressive web application features. Active participation of iOS users is not possible. For example, an app can only store local data and files up to 50 megabytes. There is no access to in-app payments or many other Apple services, and there is no integration with Siri. Progressive web application support starts from iOS version 11.3. Offline functionality is limited. Progressive web application functionality may be restricted by incomplete access to hardware components. Using a progressive web application increases the mobile device's battery consumptions. Using a progressive web application increases the mobile device's battery consumption. Examples. The Starbucks chain developed a progressive web application for order collection in addition to its regular mobile app. With an almost identical interface, the progressive web application size was reduced by 99.84%, making it more popular among users. As a result, the number of orders placed via mobile app doubled, nearly matching the volume of desktop orders. Creating a progressive web application was also a success for AliExpress. The conversion rate for new users increased by 104%, and their progressive web application's functionality helped generate twice as many page visits per session. Session duration increased by an average of 74% across all browsers, according to data from developers.google.com. Well-known companies like Twitter, Nickel, Lancome, Forbes, and others also use progressive web applications. One of the clearest examples of progressive web application is the Telegram Messenger. You can check it out at web.telegram.org. Another progressive web application I use regularly is Training Endurance, a platform for tracking workouts. Hybrid applications. Hybrid applications, as you can tell from the name, are a combination of the two previous types or a compromise between native and web applications. They are housed within a native app and function through WebView. They have access to the user's device information. Hybrid apps look and behave like native apps. They can be downloaded from the App Store and installed on the device. WebView is a system component that opens web pages within other apps. When you clicked on a link in a social network or email client, it opened within the interface of the social network or email client itself, rather than opening in a browser. This is how WebView works. In other words, a hybrid app is a web app wrapped in a native app container, which serves as a wrapper to display the web app through an embedded simplified WebView browser. The native foundation provides the advantages of native apps: access to smartphone functionalities, systems APIs, push notifications, and etc. Availability in app stores, a desktop icon, and so on, while the web app aspect offers the benefits of cross-platform compatibility and easy content updates. Some elements of a hybrid app, such as menus or buttons, may resemble elements of a native app. However, their content is developed using many of the same technologies as a web app. Therefore, most of the code is the same as in the web version. HTML, CSS, and JavaScript are usually shared between the app and the website. As with native apps, hybrid apps first require downloading an installation file. Additionally, continuous internet access is needed for proper functioning of hybrid apps. A key advantage of hybrid apps is the possibility of a kind of autonomous update. For hybrid apps, it's not necessary to release a new version every time. It's enough to update changes on the server. One obvious drawback is the weak visual style. The app is written for multiple platforms at once, so the branding style is not adapted for each of them. This is technically impossible. The most beautiful animations, transitions, and etc. will be found in native apps. The interfaces of web apps and hybrid apps have a lot in common. As examples, let's take a look at Amazon. Hybrid app downloaded from the App Store, and web app. There are essentially two ways to install native and hybrid apps. First, users can do this by downloading apps from app stores for specific platforms, such as the App Store for iOS and Google Play Store for Android. Another way is to transfer the installation file from a desktop device to a mobile device. API for iOS and APK or AAB for Android. Advantages: one code base for the web part, cost savings due to reduced development and testing efforts, easy updates of web content, access to device features. Disadvantages: performance issues, UI UX of apps is far from the ideal native apps. A separate category can be highlighted for cross-platform applications, which are sometimes confused with hybrid apps. These apps are developed using cross-platform frameworks such as React Native, JavaScript, Flutter, Dart, Ionic, JavaScript, Xamarin, Net, and C#, etc., and share common code base for both iOS and Android. However, they can be classified either as native or hybrid apps, depending on how they are implemented. In practice, you only need one developer instead of two, one who knows Swift for iOS and another who knows Kotlin for Android. Advantages: reusable code components, lower development and maintenance costs, time and money savings, faster development speed under the ideal conditions mentioned above. Disadvantages: performance issue, integration challenges, UI UX of apps does not reach the level of native apps, development complexity. You can see examples of apps built with Flutter on their website. Example of cross-platform apps built with Xamarin can be found here. Examples on React Native can be found here. A bit about the difference between cross-platform and native development. In cross-platform development, most of the code works for both iOS and Android. Then, some minor adjustments are needed to adapt the app for different platforms. You can create a cross-platform app using special frameworks. These are development environments that make writing code easier. Some examples of cross-platform frameworks include React Native, Flutter, Xamarin, and Ionic. Applications built specifically for a platform will be more secure, intuitive, and powerful, but there is another significant difference: functionality. In projects created for a specific OS, it's easier to implement complex features. For example, processing large datasets or integrating artificial intelligence. As an example, I found in the net the world-famous booking service Airbnb was initially native, but in 2016 the company decided to switch to cross-platform development to optimize resources. As a result, more time was spent on implementing features and fixing bugs. After 2 years, the team decided to switch back to native code because the cross-platform option just didn't suit the service's specific needs. As a result, Airbnb was able to add an animated map and other features. Using a cross-platform framework, this functionality could have been added, but it would have been more difficult. It's important to understand here that developing hybrid apps means that the app is built using several languages, technologies, but this doesn't always mean that it will be cross-platform. Apps can be hybrid, but not necessarily cross-platform. An app can be considered cross-platform, but not necessarily hybrid. It could be a web app or even native. For example, the React Native framework uses a JavaScript runtime environment for rendering JavaScript code and allows publishing the app in both Google Play Market and the App Store. Thus, cross-platform functionality is more of characteristic rather than a type of mobile apps. Different types of mobile apps can be either cross-platform or not. Many sources get confused and use the terms cross-platform app and hybrid app as synonyms, even so there is a distinction between them. That's all for now, my friends. This brings us to the end of the first lesson. Please give this video a like. It will really help promote it. Also, don't forget to subscribe and hit the notification bell so you won't miss the upcoming lessons. If you found this video helpful or interesting, please leave a comment letting me know. That's it from me. See you in the next video. Bye bye.